Okay, thank you very much, everybody. My background is back in 1996 when I was in the Air Force. I was at the Pentagon on temporary duty. I was at the Pentagon Library and found the book, The Case for Mars, by Dr. Robert Zubrin. So I bought it and read it, and I think I met him a year later. And I got to go to the first Mars Society convention in Boulder. And a couple of years later, I went to one after the other, and then they offered a life membership, and I scraped together $1,000 and became a life member. And I thought that was pretty cool. And what was even cooler was I got something in the mail that said that I should get an acre of land on Mars, or my family, my descendants should get an acre, split that acre up. And so I immediately went to a map of Mars, and I was looking at places where would I like to have it? And I was looking at down on near the equator, but on the edge of the Northern Sea whenever they melt that thing out. So I thought that was pretty cool. Okay, now my background is I retired from the Air Force in 2009. I was in the military space program. I was alternate treaty officer at 45th Space Wing at Patrick Air Force Base, Cape Canaveral Air Force Station. And then to round out my career, I volunteered and went to Iraq 3 times. So I needed to do my duty after 9/11. Right now, I have taught biology at high school, and I'm with a company called Noble Metals Extraction Systems. And what this company does is it puts together machines and works with the government on Superfund waste sites to draw out lead and arsenic out of poisonous sites, and also to pull out organics. It can also pull gold and silver out of those tight tailings piles because many of them are 50, 60 years old under old technology. So let me pick this mic. So okay, so my company is also a woman-owned company, and I'm a part of it. What we want to do is I want to say that all the pictures and charts from this are from various sources, so we don't claim credit for them. You're perfectly free to copy this entire briefing. Just give credit to NMES. Okay, here's my overview. Of course, I'm talking about building the initial outpost, colony, as you have it, in a lunar lava tube. These are the lunar lava tube sites that they've been mapping over the years. There are approximately 200 to 300 of them, and usually they identify them by seeing what are called skylights. So what they'll see is what appears to be first a crater, and then you notice the shadow is offset. So when a lava tube runs on Earth, it forms a crust over the top, and it solidifies, but the lava stays hot inside and continues to run out until that lava drains out. Now, on the moon, this happened, I think, billions of years ago. So these lava tubes are very old. And then if a meteor hits, it may punch a hole through that lava tube and gives you that, what I would call a skylight. So that's the way they begin to identify them. Here's some close-up pictures of some lunar lava tube skylights. And what I am looking for is a lava tube that you can enter as if you're going into a garage or a warehouse. The National Geographic Society had a special where they went to Mars. I don't know if anybody saw it, but it was like several episodes. And they found a lunar lava tube on Mars, and then they lowered everything by a crane. Now, that's great, except that I don't know if you know this or not, but on the moon and in Mars, and wearing a spacesuit in the vacuum environment, everything's 5 times harder and more dangerous. So I want it to be easy. When we set this stuff up, we've got to be as easy as possible. So I'm looking at this one right here. It looks like this might be you'd be able to go down into it, be a horizontal entry, or this one right here. These are more of the skylight type where you've just got a hole that drops down inside. Okay, the assumptions I've come up with is there's also about 20 really good locations that they appeared at, and here's a chart here of what those 20 best ones would be. Now, why be in a lunar lava tube? We've all seen the artwork of these beautiful colonies, you know, with domes and everything's up on the surface? Well, there's a couple reasons. Yes, with regolith, you can put it over the top and protect yourself. But again, that is a big construction step to pour regolith over the top of a facility. Also, the moon is always hit by something, whether it be micrometeors or mini meteors or rocks or boulders or house-sized meteors. Nothing stops on the moon until it hits the surface. And if you have a colony sitting out in the open and it gets hit by one of these things, you could have, you know, mission failure. So I think the best thing to do is to keep it inside the lava tube to give your astronauts, your habitation, the maximum protection. Also, radiation protection, coronal mass ejections, galactic cosmic radiation, that kind of stuff. When you're inside that lava tube, you're protected from all that stuff. Also, any radiation that hits the surface of the moon also has what's called secondary radiation. So radiation hits the surface and then it'll bounce back up as X-rays or gamma rays. So there's two kinds you can get. Now the great thing about the moon is the entire surface, almost the entire surface and subsurface is a mine site. What that means is there are resources all over the moon of almost every imaginable chemical and metal that you can get. Every crater is a different kind of material because every crater runs the gamut from carbonaceous chondrite asteroids to nickel iron. You don't know what they are until you get to explore them. So that's what makes the moon great. It's all a mine site. There's no trees, there's no bushes, there's no rivers you have to worry about getting in the way of. So again, the moon's a great place. Mars is also filled with resources, so same thing. Now what we would use is inflatable habitation modules. That would be what the first thing you do. And of course the ones that are made out of Kevlar. Here's a picture of a lava tube on Earth. I don't know if you guys can see that. Let me move over to this one here. This lava tube right here is the Valentine Cave in Lava Beds National Monument. You can see the young lady standing there in the middle. Now the great thing about lunar lava tubes on the moon is because of 1/6 gravity, they're going to be a lot bigger because there's less gravity. So when they formed, the gases and stuff like that evolved made them much larger. They even think that there may be lava tubes where there may be chambers back inside that are like a mile across, that are completely underground. Now, they haven't discovered those yet, but that would be pretty neat. Okay, select the optimal lunar lava tube. Right here you see these astronauts looking at the kind of the garage door. Okay, you can just go right in. You have some debris in the front, so what you're going to do is you're going to bring down, the crew is going to come down on their ascent-descent vehicle, and then they will fill regolith bags. So what they're going to do is they're going to also bring down an habitation vehicle. This one right here, this one will stay on the moon. This will not leave the moon. They will come down in one that will land and then be able to take off, but they will live in this larger vehicle at first. I'm going to call this 1HAB. So it's the first one they're going to live in. Once they arrive at the lunar lava tube that is optimal, they're going to begin to explore it with a human-robot mix. They're going to confirm that it is of the integrity they want. It's not filled with debris. It looks pretty solid. And then from there, they're going to begin to populate it. Oh, and also, does it have a skylight? Skylight would be nice because it lets light in, but that's not a necessary thing. Okay, you're going to go ahead and land a package of solar cells in order to power it during the daylight. Now, a lot of people advocate putting these things up at the poles, and the poles are great, except on the moon, the sun rolls along the horizon. I mean, it's like right down at the horizon. So the lighting you're going to get, you may get power on your solar power cells, but you're always going to have to be moving them, and the light is going to go straight across the surface. So there's going to be a lot of blackness that you'll be looking down into, and the shadows will be like forever long. So I prefer it to be right in the center of the moon. Now that doesn't mean we also want them at the pole so you can collect water, but this one near the center of the near side. You're going to need vehicles. So we're going to land a couple of medium truck quality pressurized rovers. Why two? redundancy. If one decides to die or breaks down, you can always go out with the other one, pull the one back, or retrieve the crew. You don't want to be out a couple of miles away and then it breaks down. That's not a good thing. Also, construction. You're going to be doing construction on the moon. You need things that move dirt around. So, combination front-end loader, backhoe, bulldozer. Bobcat size is great at first, then later you can bring more equipment. Now, everybody knows that on the moon and on Mars, you have a terrible problem with dust. The moon's dust is like glass dust. And Mars has what they call fines. It's very, very tiny, very microscopic. You do not want to walk into an airlock and then walk into the habitation module covered with dust, because that will get everywhere. It will get into the habitation module, it will get into the equipment, and it will begin to cause failures. So the first thing I found was a beautiful picture right here, and here's a person standing next to it to show you the size. The first thing the astronauts are going to walk into is this airlock module. Okay, you're going to bring that in, set that up inside the lava tube, and that's the first thing. So when they want to go into their habitation module, the first thing they're going to get into is that thing, and then they're going to either brush their suits off outside, and they're going to change out of their suits in the airlock module, and then they're going to go ahead and walk on into the habitation module. Now, that doesn't mean this whole thing depressurizes. You're going to have a small airlock on the side, so you don't have to change the air out in this thing every single time. But once you're in there, you get out of your suit, and the suit stays in the airlock module. It does not travel into the habitation module. So it's kind of like a mudroom. Anybody who's from up north knows what a mudroom is. When you come in from the outside, you leave all your boots and coats and all that garbage down there, and then you come up into your house. You don't track all that stuff up. Greenhouse module. That's the next thing you bring in. So the greenhouse module comes in, you bring the greenhouse module in, you hook it up to the airlock module. Because what you're going to do is you're going to first, when you go to your hab, you're going to get into the airlock module, change out of your suit, go through the greenhouse module, and then you're going to bring in the habitation module, which you're going to hook on to the end of the greenhouse module. Now you have a sequence where you enter the airlock module, then you go through the greenhouse module, and hopefully if you got any dust left on you, it comes off in the greenhouse module, and then into the habitation module. So you're never going to bring debris into the habitation module where you have all your equipment and your living quarters and that kind of thing. Now at this time, you have 24-hour daylight capability because you have the solar cells set out there, and as long as there's daytime, you can operate. Now the moon has 2 weeks of daytime and 2 weeks of night. So this is just the first thing. Once you get to about day 4 of daylight on the moon, it begins to get too hot to be out on the surface. So from then on, they can begin to explore down inside the lava tube, but you won't be going outside anymore. I don't know if you ever noticed, but when the Apollo was on the moon, they landed in the morning, and they were back inside. So they would not, they were there for a day or two, and then they were gone. So you saw very long shadows. They never came down at noon when the temperature it gets up to about 125 degrees centigrade, or that's, I think, about 240 Fahrenheit. A garage module. That's the next thing you bring in. The garage module is for your vehicles. You want to be able to bring your vehicles in out of the vacuum and to be able to work on them, brush them off, clean them, whatever you want to do. You want to do any maintenance on your vehicles inside a pressurized environment. So you're going to have an airlock module. This will be nice and large. You're going to bring the vehicles into a vehicle airlock and then on into the vehicle module itself. The fifth thing is a laboratory assaying module. The laboratory assaying module is so that you can have a place where you can bring samples in from the outside, but you will not enter the laboratory assay module in your spacesuit. The laboratory assay module you only bring in samples. You'll pass them through small airlocks that you'll put sample cases into, close those airlocks up, and then they'll transfer into the assay module. This way you can have a constant flow of material in. You can examine it for whatever is in it: iron, titanium, aluminum, gold, copper, whatever you need. you're going to be examining that, and you're going to now categorize what is in these different samples. This is my nominal setup for the facility. Airlock module, this is where you'll walk into. You'll pass through the greenhouse and into the habitation module. I thought the Flashline Mars station was a perfect habitation module to use. But instead of using this lower part as a mudroom, you won't have to do that. That can be used as a totally habitable area. Here's the garage workshop module. So this will connect by airlock. You can also connect this to the lab module because a lot of times you're going to be driving in with materials to examine. So they'll be hooked up to the lab assay module. And so this is the first setup: airlock, greenhouse, habitation, garage workshop, lab assay module. Plenty of things to explore on the moon and also later on Mars. Here's a little sample of what lunar regolith looks like under the microscope. Here are some of the chemicals that you can find in the soils. Range from barium to oxygen, magnesium, iron, silicon. Here is ilmenite, iron, and titanium. Here's the chemical structure of ilmenite. It's got iron and titanium in it. Now, the next thing you want to do, though, is you don't want to have to abandon this place at night because there's no way you can have enough battery power to make it last for 2 weeks. Earlier today, we saw the presentation on the small nuclear reactor. You must have a nuclear reactor to operate this thing at night. And also, you're going to need a nuclear reactor because we're going to be using power to do other things besides just science at this facility. Now, the great thing about being on the moon, on the near side, especially the center, is the Earth is always in the same place in the sky. It never moves. So if you're at the equator, at the center of the near side, when you look up at the full moon, you look up at the center of the moon, the Earth is directly over your head. And what's nice about that is the Earth is a lot bigger and brighter than the moon is to us. So when the sun sets on the moon, you've got a half Earth. A week later, in the middle of the lunar night, you have a full Earth. And then at sunrise, there's still a half Earth. So you're always illuminated at night on the near side. So that allows you to go out and explore around on the moon during the nighttime. Now, it does get very cold, but you're always going to have illumination. My family history, my grandfathers both worked on the railroad in Indiana. The way this country was built was by railroads. So on the moon, you're going to have a railroad system built up because these vehicles are going to drive around, they're going to spin dust. And the dust is going to get everywhere, and you've got the garage module to keep them cleaned up. But you need a rail system in order to move heavy amounts of material because what you're going to do is you're going to be going out to these mine sites, these craters, and you're going to be picking up material and bring it back because we're going to be producing an industrial facility. So you're going to be in construction of I-beams, construction blocks, rails, that kind of thing. Here's an example of a little model train on the moon. I just thought I'd throw that in there. Looks good. Okay, you're going to bring factory sets from the Earth at first. Now, most of your weight, you're going to use the lunar material, but these factory sets are going to help you to begin the process of building, forming the shapes you want, everything you want to make. So you're going to be making your own plumbing and wiring eventually. You're going to have hopper cars for raw material transport. You're going to have flatbed cars if you want to move vehicles, refine materials. And you're also going to have pressurized locomotives. The pressurized locomotives, what that means is a locomotive on the moon, it's not going to be steam, it's going to be electrically powered, but possibly you're going to have a small nuclear power plant in that train. And that nuclear power plant is going to run that train. That nuclear power plant is going to provide the power for a train that train's a spaceship. It's just on rails. It's not going to travel through space. But the moon is space. Okay, now you have a continuously crewed facility. You're going to you have now the ability to build more permanent halves. You've got the inflatables at first. Now you can build more, you can build halves of more solid material inside the lunar lava tube. But here's my big thing. We've all talked about the Hubble, and the Hubble has seen these beautiful structures in space. It's seen planets, stars, galaxies, black holes, whatever. What did they have to do when the Hubble failed? They had to send a whole mission up to see it, to go up and fix it. I'm talking about building these telescopes on the moon, 1 meter, 2 meter, putting them in rail cars. Each one's going to be a separate system. You're going to sell these or lease these to countries, universities, states, towns, individuals, whoever. And you're going to build these and put them out in a parking area. You're going to build another one and put that in a parking area. And you're going to keep building them. On the moon, you've got a vacuum. There's nothing to look through. You don't have to have adaptive optics. It's very simple. If it malfunctions, not a problem. Go out there with the locomotive, pull that thing back into the lava tube, fix it, rail it back out. It's no longer a big giant operation to fix it. Or if it breaks, it's finished. So you can see that I'm big on building the railroads on the moon because now you've got science, industrialization, and more science. And eventually, what you want to do is you're going to have a network that will allow you to go back and forth to the polar regions to collect the ice you need, for water, and also new mining sites. We're going to be building launch pads, and the launch pads, because every time something lands on the moon, it blasts dust everywhere. So you're going to build a launch pad that's cleared of all dust. And ideally, these launch pads are going to be located in such a way as that they don't blast dust into the opening of the lunar lava tube. Now, what does this have to do with Mars? Well, this shows the way. Mars also has lava tubes. This is all complementary to Mars mission. The heavy lift vehicles that deliver things to the moon, it's pretty much the same delta V as delivering stuff to Mars, except it just takes a lot longer to get to Mars. Everything's the same, though. Ground equipment, inflatable structures. So, you know what I say? This sets us up for going to Mars. This is not a stop on the way to Mars. This is, you build the materials, you build the rockets, you get the scalability of bringing down the cost of your heavy lift vehicles and of these inflatables, and then on to Mars. And here's some of my background information up here. Okay, any questions? Go ahead.
Yeah, I have two questions. One, do you know, has anybody mapped how, or have any idea of how long any of the Mars lava tubes are? Like a kilometer or length? Is there any?
I have not seen anything. I've looked. I've not seen anything on Mars lava tubes, so I'm not sure. But I think they would be fairly extensive. Mars had lava, had volcanic activity that lasted a lot longer than it did on the moon, and so I would think they would be, fairly long. But I haven't seen anything on that. I've been able to find a lot of stuff on the moon, but not much on Mars. What was your other question? I'm sorry.
And then the second is, so after you set up the temporary habitat in the lava tube, the inflatables, what could you do to make it permanent? Like, could you spray like rubber in it to make it solid, like the next generation, instead of physically having to like build a house? What is something that you think could make it more solid for later generations?
Once you have your initial setup, because what I want to do is put something in there that's easy to do. Later, you can then use the materials you mine. You create refineries and foundries. Now you can begin to build more solid materials inside that lava tube. I don't think you need to spray them because they're going to be they're going to be covered with like a thick Kevlar. I'm not going to advocate for any particular inflatable structure. We don't make them, but my whole architecture is bringing together all the technologies we've got and putting them together in this. No problem.
Have you identified on the moon
I have not personally. Sorry. The question is, have I identified any lava tubes on the moon which would be optimal? And I have not done that yet. This is my proposal that this be done. They'll have to look at them more in just, right now all they have is like a passing view. They just look down at them and see them. None have been examined, like you like dropping a robot down to it and just, taking a look inside. That has not happened yet as far as I know. But that would have to be, you want to do that first. You don't want to come up to one and find out it's collapsed before you start landing people in there. You don't want to land and then go, oh, this thing collapsed on the inside. Don't land anything else. We're out of here. Any other questions? Sir.
I believe the young lady asked about improving the durability of the inflatable. What about sealing the interior of the lava tube itself?
Yeah, that's a good question. He talked about sealing the interior of the lava tube itself. That is a very good question. I do not know of the porosity, how porous those lava tubes are, that if you could seal off, back into the lava tube, seal it, and then seal the front by putting a big, giant glass wall on it and then having an airlock that you can go in and out. That would be an excellent idea, because then once you've done that, you can pressurize the inside of the lava tube, and now instead of being just inside the habitation modules, now you can, once you walk in, yeah, you're good to go. So that would be great. I don't know how, if you could do that or not. Or maybe you could spray, like she said, spray some material, on the walls and the roof that would then make it impermeable to, the gas and moisture getting out. Go ahead.
With all the dust, all the stuff we already got, you've got the maintenance for the owner of those who have done that, like the spray, that can be what you spray on the interior wall.
Yeah, he talked about having with the lunar dust, you could make a gunite that you could mix with something and spray on the walls. That would be a great idea. I mean, once they get there and they get to examine the materials, then they'll begin to make the decisions of how they want to go forward.
Are you familiar with fourth plant logistics and Michael Dunn's work on lava tubes?
No, I am not. He asked the question, am I familiar with, who is it, Michael Dunn? Fourth Plant Logistics, I'm not familiar with that. Thank you, appreciate that.
He's doing lava tube work, and he's actually secured a lava tube in Iceland. Wormhole.
No, that's excellent. Very good. Any others? All right, thank you very much, everybody.